Hello, this podcast is about how to use a microscope. First of all, we'll go through the parts of the microscope. The eyepiece lens, which is normally times 10, is where we put our eye. The body separates the eyepiece and the objective lenses. The nose piece revolves around and holds the three objective lenses. Objective lenses further magnify the image. They are normally times 4, times 10, and times 40. The arm holds the body, the stage, and the base in place. The stage holds the slide. The clips hold the slide in place. The focus knobs, being coarse and fine, focuses the image. The condenser dictates the amount of light entering the stage, and the light is the illumination source. Quite often the condenser and the light are built into one piece, and the base provides stability. Here you can see a picture of a microscope where all the parts are labelled. We have the eyepiece lens, the body, the coarse and fine focus, the revolving nose piece, the objective lenses, the stage with clips, the light and the condenser, the arm and the base. Now, can you put all these pieces back onto the microscope? I'll give you a second. Okay, and this is where they go. Next, we're going to talk about magnification. The eyepiece or the ocular lens is normally times 10, and there are three objective lenses on the nose piece, times 4, times 10, and times 40. The eyepiece lens times the objective lens provides the total magnification. So, if we're looking at the rule, eyepiece times objective lens gives us the total magnification. The eyepiece is always times 10. The objective lens can either be times 4, times 10, or times 40. And therefore we look at the total magnification. If the eyepiece is times 10 and the objective lens is times 4, the total magnification is times 40. If the eyepiece is times 10 and the objective lens is times 10, then the total magnification is times 100. If the eyepiece is times 10 and the objective lens is times 40, then the total magnification is times 400. Now, what's this all about? Well, we have to work out the field of view. And the field of view is the distance from one side of the microscope view to the other. It's necessary to work out the size of the field of view so that it can work out the size of any specimen that's being investigated. And here's a lovely diagram of a field of view across some red blood cells. Next, we'll talk about how we work out the field of view. Well, we use a thing called a mini-grid. A mini-grid is a mini-grid. It has big squares and small squares. The big squares are 1 millimeter by 1 millimeter. And the small squares are 0.1 millimeter by 0.1 millimeter. Here you can see the big squares, and in the middle you can see the small squares. Now, to work out the field of view, we place the mini grid on the outer edge of a large square on the left-hand side, and we make sure that the small squares are on the opposite edge, as seen in the diagram. In this case, we've got 4 big squares, so that's 4 millimeters, and 6 small squares, so that's 0.6 millimeters. So the field of view is 4.6 millimeters. But with microscopy, we don't use millimeters, we use micrometers or micrometers. So there is a factor of 1,000 that we need to consider. With the field of view at 4.6 millimeters, if we times that by 1,000, we end up with 4,600 micrometers. That symbol behind the 4,600 is a Greek M, and that means micro. Okay, so the effect of magnification on the field of view. As magnification increases, the field of view decreases. So if the magnification goes up from times 40 to times 400, which is an increase of times 10, then the field of view must go down from 4,600 to 460 because it's been divided by 10. When we increase the magnification, the object we're looking at doesn't increase in size. We just see it larger. So let's do some calculations about changing the magnification and seeing the effect on the field of view. In this case, we know at magnification of times 40, the field of view is 4,600 micrometers. If we go from times 40 to times 100, that's an increase of 2.5, which means that the field of view needs to be divided by 2.5. And so 4,600 divided by 2.5 is 1840 micrometers. Then if we go from times 100 to times 400 in magnification, which is an increase of times 4, field of view needs to be divided by 4. So we go from 1840 micrometers divided by 4 is 460 micrometers. An easier way to do it might be to say if we went from times 40 to times 400, which is a factor of 10, then the field of view needs to decrease by a factor of 10. So a tenth of 4,600 is 460 micrometers. Now to make a slide, we call making a slide a wet mount. And there are steps to making a wet mount. First, we place a sample on a clean slide. We place a drop of distilled water on the sample. We place a cover slip at a 45-degree angle next to the sample, and we hold the cover slip up in place with forceps. A probe will do also. Slowly, we're going to lower the cover slip as this allows air bubbles to escape. We can then view the slide under the microscope, hopefully with no air bubbles. The last thing we're going to talk about is biological drawings from what you see down your microscope. Be sure to use a soft lead pencil for all your drawings, your labels, your name and other information, and be careful not to smudge your drawing. Use only unlined paper. Put a title on your drawing in the middle at the top. Your drawing should be approximately 1/3 of your page, and keep your drawing to the left-hand side of the centre to allow for your labels, which will appear on the right-hand side. Use a ruler to draw lines from the object to the label. Never cross over the lines, and do not use arrowheads on any of the labelling lines. Do not use plural labels unless you have to. Always show the magnification of your image to give the viewer a perspective. Only draw what you can see. Do not include additional structures that you think should be added. Do not shade or sketch. All lines should be solid and complete. And then finally include your name and the date at the bottom of the right-hand side of your drawing. Thank you for listening. Don't forget to like and subscribe. Goodbye.